Okay. Hello everyone. Welcome to the POMO Livesolve. Um, so if you guys participated in POMO 1, thank you for your participation. Did you guys enjoy the problems? Yeah. Um, so so to start, let's have Ethan go for opening opening remarks.
Good evening to you all. I suppose most of you know me already, but if you don't, my name is Ethan Gabriel Shimo. I am honored to be one of the live solvers of the recently concluded POMO 1, a mock Philippine Mathematical Olympiad that aims to prepare students for the upcoming 28 PMO. It's also an honor to be with you tonight. As a member of the POMO staff, I stay true to the belief that we joined POMO not because we are forced to learn equations or learn formulas by rote. We are here to understand that mathematics is mental gymnastics. It is a world where various fields intertwine together. Here, we see the intricate beauty of geometric figures, along with the analytic nature of algebra and combinatorics. In mathematics, we learn not to think in only one dimension. Rather, we learn to see things from multiple perspectives. And that is what makes the realm of mathematical thinking beautiful. To all the POMO contestants, a word of congratulations goes from me to you. Regardless of whether you got distinction, credit, or proficiency, all of you are winners. But success isn't solely based on your scores. It is based on your attitude towards learning. That is why Winston Churchill told us, success is not final, failure is not fatal. It is the courage to continue that counts. Even though we may gain a sense of accomplishment because of solving a difficult problem, what's more important is that we realize how the field of computational mathematics contains problems that are fun, engaging, and interactive. Furthermore, training for mathematics competitions, especially for a large-scale one such as POMO or PMO, is not an easy task. It requires the courage to persevere despite being unable to solve a problem at first glance. We want to understand the motivation and the theory behind each problem. And tonight, we will be doing that. That's how each one of us can become a better thinker and ultimately a better problem solver. Again, welcome to our discussion session for POMO 1 and good evening.
Okay, thank you, Ethan. So with that, um, let's start the type solve. So we will discuss all the problems in order, and so if you want to like hear part three, we will discuss it later on in the session. So introducing our speakers. So I'm one of them. And then we also have Ethan Ngo, Mateo Esposha, and Job Dominguez, and Cody Bionis also. So is everyone allowed to participate? You can ask questions if you want and like build ideas in the chat. That is highly appreciated also. So yeah, I guess we'll start now. Ethan, we'll start now.
Okay, for the first problem, a flock of pellicular penchicks pick pickled peanuts, peppers, both or none. Particularly, one third of the penchicks pick pickled peanuts, 1/7 of the penchicks pick peppers, and 1/12 of the penchicks peck pickled peanuts and peppers. What fraction of the penchick flock pecks neither pickled peanuts nor peppers? Cannot open it, so I will annotate here. Without loss of generality, assume that we have 84 penchicks in total. Then, 28 of them pick pickled peanuts, 12 of them pick peppers, and 7 of them pick both. Because of this, we have the motivation to use principle of inclusion and exclusion, also called pi. From there, we have 28 plus 12 minus 7, which gives the total number of Penchicks that picked anything. So 1 minus 33 over 84, because 33 is the number of Penchicks that have picked at least one of the things. So subtracting those, we get 51 over 84, which gives 17 over 28. Thus, our answer is B. Bateria.
Okay. To add, you can also if you can also do it like the normal way. You can like do 1/3 plus 1/7 minus 1/12, but still the one that Ethan provided is easier. So just letting you know that it's also a valid solution. Okay, next.
Before I move on to problem 2, so 1 minus 11 over 28 equals 17 over 28. That's correct. For the second problem, find the remainder when 5 raised to 11 plus 11 raised to 5 is divided by 14. First, we have this equation. 5 raised to 11 plus 11 raised to 5. And then we can use this technique. Basically, we can rewrite the left term as 25 raised to 5 times 5, and then use this 11 raised to 5. All right. Now, our motivation here is to rewrite this as negative 11 times 5, negative 11 raised to 5 times 5 plus 11 raised to 5. Now, we have this. Plus, wait a sec. Oh, this is supposed to be positive, guys. Sorry. Yes. And then we have 11 raised to 5 times 6. And then by modular inverses, we get the following. Negative 3 raised to 5 times 6. And then 81 times 6 times negative 3. From this principle, we have 66 times, times 11, which is 674. Now let's just use standard long division to find the remainder. Over here we get 56 minus 56, and then this is 114. And then the lowest number, that is okay, wait, I seem to have made an arithmetic error somewhere. Yeah, we have negative. Okay, going back to this. Okay, let's go back to this. So we have negative 243 times 6. And this gives 6 times. And then this gives 6 times negative 5, which is basically negative 30. Therefore, we can use modular inverses to show that the answer is D. And again, before I proceed to number 3, okay, this method is also correct. So thank you, Karsten, for that. Now let us proceed to part 1, number 3. Guys, can you scroll down? All penchicks are independently assigned exactly 2 traits, where each possible outcome within a trait is equally likely to occur. A feather color can be black, gray, and white. Birthday of the week, Monday to Sunday. Denise has exactly 2 distinct penchicks. Given at least one penchick satisfies both the conditions of being gray and born on a weekend, what is the probability that both penchicks are gray? The answer is 3 over 10. But here is the solution. So we have 3 feather colors times 7. That gives us 21 distinct characteristics. But since it said that, but since it is given that at least one penchick satisfies both the conditions of being gray and born on a weekend, gray and born on a weekend. So this means that these are the so this means that only one out of them has one on. So yeah, okay. Apologies, I do not know the solution. May I? I'll give the floor back to you, Kaiser.
Okay, hold on. Hold on. Uh, I guess you can go for number 4 first.
Let us skip number 3 for a while. Let's go back to that one later. Penchick has a 20-sided dice. She rolls it and gets the running product of the numbers she rolls until she generates a product that is divisible by all prime numbers less than 20. The least number of rolls to do it is A, and the least possible sum of these numbers for A rolls is B. Find A plus B. All of the prime numbers that are less than 20 are 2, 3, 5, 7, 11, 13, 17, and 19. These all contribute 8. So these are 8 rolls. And from here, we can see that the least possible sum is 60, 72, 75, and 77. Therefore, we have an answer of 85.
Okay, thank you.
This isn't the least number, by the way.
Yeah. Okay, thank you. Mateo, Mateo said he will do number 3. So let's go to that first before number 5.
Wait,
1 second.
Go lang.
Okay, erased.
wait. Okay. Hello everyone. So I'm one of the solvers. I did not join this contest, so I just got invited. Okay. Anyway, so we have here a conditional probability problem. So it's type of problem where given some condition, what's the probability that this other condition is given? So first we commit how many uh pairs of penchicks have both of the conditions of being gray and born on a weekend. So to do this, um, what we can do is we consider, okay, so we have 3 possible feather colors and 7 possible days. So we have 21 squared possible pairs. And then out of those pairs where no penchick is gray and born on a weekend. So you have either you have gray Saturday penchicks or gray Sunday penchicks. So that's just 2 of the 21. So which means that's 19 squared. Or so the number of penchick pairs where at least one satisfies both being gray and born on a weekend is 80. So that's a denominator uh in our final answer. So you have over 80. So just from this, actually, you can just guess that D should be the answer, but we'll just complete this just for clarity. Okay. Anyway, we need out of these, how many possible ways are there where both penchicks are gray? So um so one case is possible is that I let's say we have, okay, suppose Penchick, the first Penchick is gray and weekend, born on weekend. So we just see the second one to be, we just see the second Penchick to be gray. So which means there are 7. So oh wait, no. So there are two ways for this first Penchick to be gray and weekend, and then so the other Penchick, so gray and then any of the days of the week. So it's 7. Wait, okay. Suppose the other one is not a weekend, and the okay, second Penchick is not a weekday. Weekday. So that's 2 times 5. And then for the other way around, so let's say second Penchick is the one that's gray and born on a weekend. It's just the same value. So it's like 2 times 5 here. First is on a weekday. Then finally, the case where both are gray, both are gray and weekend. So that's 2 times 2. So summing all of these values, we get 10, 10, 10, 4. So that's 24 out of 80, or 3 over 10. Okay, so this okay, so just ask questions in the chat if you don't get some part of the solution. Anyway, um, in problem 4, it's when we discussed. So the answer here is not 85. That's a common mistake. So the way to get 85 is assume that every prime number should be rolled. So 85 is equal to 8 plus 2 plus 3 plus 5 plus 7 plus 11 plus 13, etc. But the most important part is this: the least number of rolls to have
Uh,
the product is A. So to minimize this, we can multiply some of these one-digit primes, and we can actually get 6. So we get 2 times 5 is 10. I know 2 times 7 is 14. 3 times 5 is 15. And if you try 5 here, obviously it would be possible because 2 times 3 times 5 times 7 is 200 already. 210. So A is equal to 6. And one can confirm that the least sum is 14 plus 15 plus 11 plus 13 plus 17 plus 19 here is equal to 89. And so the answer here, this is the wrong answer. So the answer here is 95. Okay. Anyway, okay, that's it.
Before we move on to number 5, do we have any questions in the chat for 3 and 4? Or for 1 to 4? Okay. I guess none. Just a reminder that that we encourage everyone or many people to discuss we encourage everyone to discuss the problems in the chat also, and build up ideas it, and collaborate in the chat while we do the live solve. And if you have any questions, please don't hesitate to ask. Okay, now let's move on to number 5. I'll be the one to present the solution. Okay. Oh, why is the first solution wrong for number 4? Mateo. Why is number 5 so easy? Okay. Anyway, the question for number 4 is answered, so we'll move on to number 5. So, I actually like the solution here. Um, so I'll read the problem first. In the diagram, let H be a point on a circle with diameter TU of length 24, such that angle HUT is 30 degrees. And then let C and A be points on the same arc as H, uh, s- so that the minor arc HT is equal in length to the minor arc CA. So basically oops, my bad. Uh, so basically the two arcs in brown are have the same length. And segments AC and HT do not intersect. So find the integer closest to the area of the shaded region bounded by minor arc CH, segment HU, minor arc UA, and segment AC. So essentially the shaded region. Okay. So the nice solution here is you can slide this chord, the AC, to here. So that A equals U. So slide, wait, no. Uh wait, okay. So slide arc CA so so that A lands on U. Wait, yeah. So that A lands on U. Then the nice thing here is let's name O as the center of the circle. Then I'll draw this line. So this is C prime and this is A prime. Uh I'll draw CO, and then I'll also draw HO and CH. So you should notice that wait. You should notice that wait, this is X. You should notice that HOX is congruent to C prime A prime X. No, A prime C prime X. So I'll write that down. So it's congruent to A prime C prime X. And the reason for this is uh, reason for this is since triangle C C prime A prime O is equilateral, and angle CAX, so this is wait C prime A prime X is 30, and X prime C prime A is 60. Um so essentially it's gonna be like, what do you call, yeah, okay. So going back, this is equilateral, and then this is 30 degrees, so this is also 30 degrees. So that means that this is 60 degrees. So essentially you have 30, 60, 90. Okay. And then this will mean that C C prime X A prime is a right angle, and since it's it's a vertical angle with this, you also get that this is a right angle. Okay. And then the equilateral triangle also indicates that HO equals C prime A prime. And then you also have wait, yeah. And then and since these are equal, wait, no. And you also have this one due to the wait, what is going on? Delete this. And you also have OX is equal to okay. OX is equal to C prime X because because the HU bisects side C prime O, due to the 30 degrees. Are you good so far? Okay. And now we have that these two triangles are congruent. So wait. So that will mean that we can move the shaded okay, so now let's go back to the areas. So essentially the new area will look something like, we'll use a highlighter. It will look something like this, right? So wait, wait lang. Oh no. So it will essentially look something like this pala. So this is a straight line. And then so since we have two congruent triangles, I'm going to split this the yellow region into two regions. So this is the orange one and then the green one. And then since we have this, we know that the green region, so C prime A prime X, has the same area as HOX. So we have that. Good. And now the new region, it's this one. That's a 60-degree sector. So the area of that is just 1/6 of the entire circle. And since TU has length 24, the radius is 12. So this will the area of the circle will be 12 squared pi or 144 pi, and then you divide by 6 to because this is the 60-degree sector. Okay. So this is hold on. Yeah, so this is supposed to be 24 pi. And the integer closest to that is 75, so that's B. Do you have any questions? Yeah, this problem kind of takes a long time. Uh, the, I think the approximation might take some time also, and maybe the insight itself. So, do you have questions? Okay, I guess we don't. So we will move on to part two. We'll now move on to part two. So these are the 2-point problems. Okay. So we'll start with number 1. An inscribed circle is internally tangent to all four sides of a rhombus that has diagonal 6 and 8. So firstly, I'm gonna draw that rhombus. This is a classic problem in geometry. So it would be nice if you're familiar with this. So diagram looks something like this. It's not drawn to scale. And assume that the circle is tangent. I'll try to draw it better. Yeah, so it looks something like this. Just assume it's a circle. And now we're supposed to find the area of the circle. Can be expressed as a over b times pi, where a and b are relatively prime positive integers. And then we're supposed to find a plus b. So, okay. So how we're supposed to approach this is we're I'm gonna name the points. So let's call the rhombus for instance A B C D. Okay. And then this point O. Wait, I'll just put it here. And then I'll name this point X. So we're gonna draw this line segment. So this is the um radius of the circle. And we know that the diagonals of the rhombus are perpendicular to each other. Right? So that means we have a right angle here and triangle AOB is a triangle AOB is a right triangle. So we draw X. Uh let it be the point of tangency. of circle O to AB. And we also know about something about tangents. We know that this is a right angle. So that's angle BXO. And this is great because we can just find the length of OX. We can use areas for this. So we know that BO is 6 and AO is 8. So meaning that twice the area of AOB is 6 times 8, so that's 48. And we can also compute the area using OX times AB over 2. And yeah. So this is also OX times AB, but we know that by the Pythagorean theorem, AB is 10. So this is 10 OX. So 48 equals 10 OX. I'll just put a dot here. And so we get that OX equals 48 over 10 or 24 over 5. I'll just move this down. And so that means that the radius of the circle is 24 over 5. That means that the area of circle O is pi times 24 over 5 squared. So that is what's this? 5. Wait, hold on. Just gonna change something. Oh, my bad. Just need to wait lang. Oh, okay. This is my bad. BO is half of the diagonal, so that is 3. And then AO is 4, so that's 8 over 2. And the area is 12, not 48. And then so 12 equals 10 OX. So that will mean that OX is 12 over no. Wait lang. Just fix something. No, no, no. And this is 5 also. So that means that this is 12 over 5. Radius is 12 over 5. Sorry for that. And that will mean that the area is 144 over 25 pi. And therefore the answer is 169. Yeah, people seem to get a solution in the chat. That's good. Uh yeah, you can also do the inverse Pythagorean. So I just showed the area thing here for those who don't know it yet. And so essentially you just get the altitude using BO times AO over AB. Okay. Yeah, and we use brackets for areas. So if we have no questions, let's move on to number 2. So the question reads, let X be the number of ways. Oh, can you scroll down? Okay. Let X be the number of ways to rearrange the letters of the word Oompa Loompa such that the word contains POMO but not PMO. So POMO and PMO must be beside each other or contiguous substrings. So find the first 3 digits of X. So essentially the solution goes like this. Okay. I'll state the answer later. If the rearrangement contains at least one POMO, then we have 3 possible kinds of words. Okay. So after looking at the letters, you can see there's 2 P's, 2 M's, and 4 O's. So that could mean that wait. So that could mean that you can have 2 POMOs. Okay. You can also have 1 POMO and 1 PMO. Make sure you see why. Or you can also have 1 POMO and 0 PMOs. Okay. So let the number of ways we can rearrange them in each of these three cases be A, B, and C respectively. Then that will mean that POMO not PMO will be either A or C. So I'll highlight that. So these are the cases that we want. So so that will mean that X equals A plus C. Thus we can evaluate X by finding B and A plus B plus C, because that way you can just do A plus B plus C and then subtract B. So essentially complementary counting. Are you good so far? Yeah, I guess we are. So sige. Let's move on. So first let's compute B. So the word contains 1 POMO and 1 PMO. So treating POMO and PMO as contiguous substrings S and T, we rearrange the letters of wait. So essentially we let POMO be S and then PMO be T. Then that will mean that we rearrange the letters of this word, because this one you can just replace with S, and then and then this one you can just replace with T. So that will so we have two A's, right? So that means that we can do this in 6 factorial over 2 factorial, which is 360 ways. So B is 360. And then for A plus B plus C, that will mean that the word contains at least 1 POMO. So if we treat POMO as one continuous substring, then you can just replace these first 4 letters with S. And it will be this word, right? And we have 8 factorial over 2 factorial ways. This is 10080. However, we have double counted the words which contain 2 POMOs. So we do complementary counting again. So we subtract this word salsa. So reason for this, you just replace this one also with S. All right. Do you have questions? Okay, wala. So and the number of ways we can rearrange this, there are 2 A's. Also here there are 2 A's, 2 O's. So this one will become 5 factorial over there's also 2s. 5 factorial over 2 factorial 2 factorial, which will be 30. So that will mean that A plus B plus C is 10050. Okay. Therefore, X is 10050 minus 360. So that's 9690. And therefore the answer is 969. Okay. Do you have any questions? I guess we don't have any. So let's move on to part 2, number 3.
Okay, hello. My name is Joe Dominguez, and I will be solving problem number 3. So let's just start already. Penchick is thinking of a number A and tells you the following. A is the product of two positive integers, P and Q. A is a 2-digit number. P is also a 2-digit number. And Q is a 1-digit number. And this statement now states there is exactly one pair P and Q that which satisfies the above conditions. How many numbers A satisfy the above condition? So let's go first with the to the last statement here. Clearly, we know that P, Q must be A and 1, right? We know that this must be the unique pair. Oh, my bad. Unique pair. So basically, this question is the ultimate problem here is to find A equals to P times Q such that P and Q are less than 10. So that there's only one unique pair and that A and 1. So let's divide it into two cases. We can have here the first case if A is prime. And then the second one, A is not prime. Okay, so clearly, A being a prime number always works because that means that the only unique pair is A and 1, since of course A is just a prime number is just the factor is 1 in itself. So there are a total of 21 numbers, 21 prime numbers that are greater than 10. So now let's go over to the second case where A is not prime. So let's say A is equal to Q times Q prime, right? And we want Q and P prime to be less than 10. And let's say Q is greater than or equal to P prime. Oh, I also forgot to mention that Q must be greater than or equal to 2, since it is now a divisor of A. We can define that Q must be a prime number. And why is that? For example, let's say if A is equal to, let's say Q is equal to, let's say 4, right? And let's say A equals to, 4 times 5. There is still another pair, which is still 2 times 10, which also contradicts the case. So basically, we don't have to check all the Q that are all Q from 1 to 10, but only check the prime numbers because we can still minimize the Q basically. So now this problem just becomes to like a counting problem. So we'll just check all the from Q being a prime number from 1 to 10. So let's start with 2. So P prime, what works are 5, 6, 7, 8, 9. Then Q equals to 3. What works, I'm pretty sure was 5, 6, but then we already counted 6 here from 2 times 9, so we don't have to double count it anymore. We just have 5, 7, 8 doesn't work. 8 times 3 is 24. But then you can read it as 4 times 2, which is not allowed. Then but 9 works. 3 times 9, 27. It's not the case after that. Let's say for Q equals to 5. I'll go down after. Sorry for I'll go down. Q equals to 5. P prime. We can check 5 times 5 works. and 7 works. Then Q equal to 7, we can only see that P prime is equal to 7, given with our conditions in the top here. So we can count how many ways that we have here, or how many numbers that satisfy. So we have here 5 ways here. There's 3 way. There's 3 ways here, 2 ways, and 1 way. So now with both of our cases done, we can count now the total number of cases. 21 plus 5 plus 3 plus 2, 1, comes up into 32, which is letter C. So I will clarify again for case 2. I think I didn't stated properly on why we have Q must be a prime. I'm sorry for that. Let's go back. Q again must be we can just find the cases when Q is prime, because if let's say Q is a composite, we can still minimize um the pair into its distinct prime factor, the smallest prime factor. What makes a valid P prime for Q? A P prime, it's stated here that P prime must be less than 10. Why is that? Because going back to our conditions here on the left side, it's since if we want to make A1 as a unique pair, if A1 is a unique pair, we need both P and Q to be less than 10. Does that answer your question? Okay, Minjushi says, A if A is considered a semi-prime, no, because let's say for your example 93, you can still write it as 3 times 31, but we only wanted to our case to be A and 1. Okay, we don't this will count as another pair. Does that answer your question? Okay, that's nice. Do you still have any other clarifications for this problem? Are there none anymore? In that case, I think we can go to move to the next question.
Yeah, I suppose we're already ready with the next question, right?
Yeah, you can continue.
For all integers n is greater than 1, let f of n be the biggest proper divisor of n. Find the sequence as a sub 1 equals 2, and a sub I plus 1 equals a sub I plus f of a sub I for all of I is greater than or equal to 1. How many terms in the sequence are proper divisors of a sub 20 times a sub 25? Note, a positive integer m is a proper divisor of an integer n is greater than 1 if and only if m is divisible by n and m is less than n. Okay, so if f of x is even, we have f of x equals to x over 2. And so x plus f of x is equal to 3 over 2x. If f of x is odd, and if 3 is divisible by x, we have f of x equals to x over 3. X plus f of x is equal to 4 over 3x. By induction, we have a times 3k minus 2 equals to 2 times 3 raised to k minus 1. then a times 3, a sub 3k minus 1 equals 3 raised to k. Thus, we have a sub 3k equals to 4 times 3 raised to k minus 1. From this pattern, we have that a sub 20 equals 3 raised to 7, because we know that 20 is 2 mod 5, and a sub 25 is 2 mod 30. 2 times 3 raised to 3, 2 times 3 raised to 8. Thus, this is 2 times 3 raised to 15, and there are 16 times 2 equals 32. We cannot count 1 because it is already stated in the problem, and we cannot count this number itself. Thus, there are only 30 proper divisors. Thank you.
Okay, we now move on to number 5. Going back to Job.
Hey, we're now going to the geometry territory again. So let's start. Oops. Let ABC, ABC is a right triangle with angle B being 90 degrees. Let's draw that first. Down. We have B, A, B, and C. Oops. A, B, C. ABC is a right triangle with angle B being 90 degrees. Let D, E, F be on sides BC, AC, and AB, where BE is perpendicular to AC. Let's do that. Sorry for my bad drawing over here. Or let's say this one. It is E, and angle CED and angle AEF are equal to 45 degrees. So D again is on side BC, and it's bisecting the angle BEC with a given condition. So let's do that right now. Say here. That's D over here, and this is, let's say, it's F. Okay, here's F. Then CED is equal to CED is equal to AF is equal to 45 degrees. Draw that right now. I will just be given now 45, 45, 45, and 45. Now, if FE is equal to 2 and B equal to 6, and the area of ABC is P over Q for some relatively prime positive integers P and Q, let's find P plus Q. Okay, so we will have here this one to be 2 and this one to be 6. Is it clear for other people here? I think it is, hopefully. So now let's draw the F over here. So to start off, we can clearly see that DE is an angle bisector of the angle BEC. So again, DE, what happened over here? I'm very sorry. DE is the angle bisector angle BC, and same for FE. Of BA. So now, we can clearly see there is a set of similar triangles over here. Um, we can see that this angle is equal to this angle. You can try to just angle chase it since these are similar triangles. AEB and triangle BEC are similar triangles with these angles denoted by the color green being equal. So this means with the equal angles of the green and the blue, 45 degrees, we can say that the triangle AFE is similar to triangle PED. So this means that by the ratio, using the ratios, we have result A1. I need to move the problem below. We have here AF is equal to BD is equal to, let's say, FE. What's happening? My bad. FE is to D, which is actually equal to 1 over 3, right? Since 2 over 6, 1 over 3. So now we will use a type of technique. We can just do length chasing here, and what that means is if you set length to be side length x, you can try to find other lengths in terms of x. So here, we could start with for AF to be x. So this means that BD would be 3x. Oh, also, I forgot to mention that I forgot to add this. I'm very sorry. Angle side AE for here in the similarity AE equals to AE over BE is also equal to 1:3, right? And actually, we can use now a very useful theorem here that includes angle bisector theorem. And that is, if you have, let's say, a triangle over here with angle bisector that bisects these angles, this means that these side lengths, the ratio of those side lengths is the same as the ratio of these side lengths, respectively on their placement. So, using that, theorem, we can have here AF over BF is equal to AE is to B3, BE to B3, which is actually equal to 1/3. So this means that BF is equal to 3x. And now with this, we actually have here a right triangle, of course, in triangle BED. And now we can actually solve, we can just find that, no. Actually, wait, we forgot something very fun. My bad. We should find as well BC in terms of x. We can find CD in terms of x with the same type of ratio. We have here with I'll just write it down here. The triangle AEB is similar to triangle BEC. I forgot to mention it over here. Which means that uh, which means that what do I write? I just write over here. AE is to BE is equal to BE is equal to BE, which means that CE is just equal to 3 of BE. And with that, we can also again use angle bisector to triangle BC here. We can use it over here. And we will have BD over CD is equal to BE over CE, which is again equal to 1, 3. So we will have here CD is equal to 9x. 9x. Are you guys still following, or is it a bit confusing here? So we'll just continue again. So now we can try to find the area of ABC in terms of x with the given lengths. Seeing this, we actually have a right triangle here. Triangle BEF, because angle FEB and plus angle BED is 45 plus 45 equals to 30 degrees. So now we can try to find the length of that triangle, which is 2 squared plus 6 squared, which is equal to square root of 40. Let's say we'll just say 2 squared 10. Okay, check here. 2 squared 10. And now we can try to find the value of x in terms in triangle BDF. So in triangle BDF, we have, by Pythagorean theorem, we have 18x squared, or 18x squared is equal to 2 squared times squared, or that will be equal to 40. And actually you can see that in triangle ABC, the area of ABC is just equal to 4x times 12x over 2, or simply 24x squared. So we can just try to solve for x squared, right? So x squared here, we can solve that, which is 10 over 9. Then we can just substitute that now. Here, 24 times 20 over 9. Cancel here 8, 3. We have here 160 over 3. And if you're on prime, we have here 160 plus 3 is equal to 163, which is letter C. So again, recap here for this problem is to see that from the given statement here of CED and AEF, this implies like you can see that there will be angle bisectors, and see that you can also have here similarity of triangles later on. And as well, we can actually see that triangle the quadrilateral BDEF is a cyclic quadrilateral. And that's about it for this problem. So yeah, we can go to the next question. Thank you.
Thank you. Let's move on to number 6. So I'll be presenting this one. Okay, this is in fact my problem. And yeah, okay. So I'll read the question. Let A equals let A equals C minus root D and B equals C plus root D. So basically they're conjugates of each other. Where C and D are integers and D is non-negative and not a perfect square. Be real numbers satisfying this thing. So that's A squared plus B squared equals 2 minus 4 times A plus B. And then we're supposed to find A squared plus B squared. Okay. So So the idea here is to substitute C and D into the equation. So once we do that, we're going to get C minus root D squared plus C plus root D squared equals 2 minus 4 times C minus root D plus C plus root D. Or if you simplify this, so you can expand this and simplify it also here. Note that many terms will cancel. That will give us 2c squared plus 2d squared equals 2 minus 4 times 2c. And then you can rearrange this once again. Wait. By the way, this is 4. And then you can rearrange it again to get hold on. Okay. And then you can divide by 2 and then rearrange stuff. So you get that c squared. Wait, no, this is not d squared. This is d. You get c squared minus 4d, 4c rather, plus d equals 1. Okay. Now, notice that c squared minus 4c are the first two terms of a perfect square trinomial. So that means we can complete the square. Okay. Then we get that c plus, wait. Then we get that c plus 2 squared plus d equals 5. And then from here, you can check that you can check on your own that d equals 5 is the only possible value of d that is non-negative and not a perfect square. So basically according to the conditions of the problem. Okay. Then that will mean that c plus wait, that will mean that c plus 2 squared equals 0, right? Then that will mean that c plus 2 is 0 or c equals negative 2, right? And then you can just go a squared plus b squared equals 2c squared plus 2d. You can just substitute that. So that's 2 times negative 2 squared plus 2 times 5. And you're supposed to get 18 as the answer. So that's A. Okay, do you guys have any questions? Okay, I guess none. So let's move on to, oh, there's a chat. Oh, okay, never mind. Yeah. Oh, C minus. Oh, it's C minus 2. My bad. Wait. Yeah, it's C minus 2. It will become C equals 2, but it shouldn't change the answer anyway. Okay. So, okay. Do you have any more questions? Okay. If none, let's move on to number 7. So we're back in geometry. This time areas again. So a right triangle is inscribed in a circle as shown. If the ratio of the circle's area to the triangle's area is 2 pi, find the smallest angle of the triangle in degrees. So I drew the diagram here. So let our triangle be ABC. Let O be the center of the circle. Okay. So I drew ABC so that B has the right angle. So angle ABC is 90 degrees and then AB is less than AC. Okay. So notice that since the triangle is inscribed in the circle, we know that O is on AC, meaning that AC is a diameter of circle O. Okay. And then, hold on. Okay. So now let R be the radius of circle O, and H be the height from B to AC. So if we draw this, it will look something like this. This is a right angle. So this is H. Okay. Then that means that we have since we have area of circle O equals 2 pi times area of ABC as per the problem statement, you use the formulas. So pi r squared equals 2 pi times 2 RH over 2. Okay. So essentially this one is 2r since AC is the diameter. Okay. And then you can cancel stuff. You can cancel pi. You can cancel this. You can cancel one of the r's. That will mean that r e equals 2h, or h equals r over 2. Okay. Just move this down. Hold on. Okay. So going back. So again, so if we let O be the center and D be the midpoint of arc AC containing B, so basically we want these two to be equal, and then we position D here. Okay. So since H equals R over 2, right? That will mean that B must lie on the perpendicular bisector of DO. So if we draw this and then this, right? This is a right angle and these two are equal. Okay. Then that will mean that DOB is equilateral. Wait, I'll just write that down. Wait. Right. And then okay. And then that will mean that okay. So essentially it's like this is also H, and then your R is this, and this also R, and O OD is also R. Okay, we good with that? Yeah, a lot of people here use trig. It's also a valid solution. I'll present it later. And since triangle DOB is equilateral, side lengths are R. That's DO equals OB equals BD equals R. That will mean that angle BCA, so it's an inscribed angle. That will mean that it's angle BOA over 2, right? So we know that this is a right angle. Angle AOD is a right angle. Wait, I'll just write it. So BOA is AOD minus BOD over 2. So that's 90 degrees minus 60 degrees because 60 degrees because BOD is equilateral over 2. And then this is 15 degrees. And that's our answer. So I'll present the trig solution also. I have to move this down again. Wait down. Okay, there we go. So solution 2 is as follows. So if we let 2r be the length of the diameter, so that's AC, and then theta be the smallest angle, okay, then the sides will be, hold on, yeah, then the sides will be 2r sine theta and 2r cosine theta. So this will be, wait, yeah, so this will be AB and and BC respectively. Good. Okay. And then that will mean that the area of the triangle ABC is 2r sine theta times 2r cosine theta over 2. So that will be like r sine, okay. So that will be like r times 2 sine theta cosine theta, and this should look familiar because it's equal to sine 2 theta. So you write this. Okay. And then now we use the ratio being 2 pi. So that will mean that wait. So that will mean that pi r squared equals r sine 2 pi 2 theta times 2 pi. You can cancel this. So that means that wait. Oh, this r squared. My bad. And you can also cancel r squared. Right. So that will mean that sine 2 theta is 1/2. And that will already tell you that the 2 theta is 30 degrees, so theta is 15 degrees. And therefore the answer is B. Okay. Do we have any questions? Yeah, okay. So it looks like lots of you use trig. That's fine. Just as long as you solve it, I guess. Okay. Do you have questions? Okay. So you still have time. We'll end at maybe around 10:45. So we'll just schedule another session later on in a few days. So now let's discuss number 8. Okay. So in triangle ABC, let AB and C be the angle sizes. So essentially just angle A, angle B, and angle C. So if tangent A and tangent B are the roots of 6x squared minus 60x plus 1 equals 0, so you have a polynomial there, then we have to find the absolute value of cosine C, which is written in this form. Okay. So, sige. So firstly, using Vieta, we'll see that the sum of the roots of the polynomial is negative of negative 60 over 6. So that will be 10. And then tangent A times tangent B equals 1 over 6. Okay. And then this tangent A plus tangent B and tangent A tangent B should be familiar. Why? Because you can use this trig identity. So tangent of A plus B equals tangent A plus tangent B over 1 minus tangent A times tangent B. Cool. So that will mean that this is 10 over 1 minus 1 over 6. Or 10 over 5. 10 over 5 over 6. So so you're supposed to get that this is 12. Okay. And A plus B is 180 minus C, right? So that will mean that tangent of 180 degrees minus C equals 12 also. Okay. Then that will mean that tangent C is just the negative of that. So tangent C equals negative 12. Okay. And then you can envision this as like right triangle. Uh, so let's say you have C as C as this, then you can let this be 12 and this be 1, and then this will be square root of 145 by Pythagoras, right? And then you're supposed to get that cosine C is 1 over root of 145, leading you to the answer of root 145 over 145. So essentially, this is 1 times root 145 over 145. We just put the A there to, yeah, to trick people, I guess. So the answer will be 291. Okay. Do we have questions? Yeah, I guess tangent identities are not as well used as sine and cosine, but I guess people will still ask them anyway. Yeah, you can also do it with tan A plus tan B plus tan C equals tangent A tangent B tangent C. Hold on. So yeah. Yeah, it's not too hard. I guess you just need to know like beta and trig identities. Okay. Do we have any other questions about any of the questions so far? Okay. If none, then yeah, I guess we should trig is used in a fair amount of questions. Does IMO have a lot of trig? I don't think they ask it too much as like this type of algebraic trig, but this shows up in like many short answer contests. Like I saw there's a Mathera question also with trig roots. Yeah, it has nearly none, but I guess you can use trig anyway in like geometry. Okay. So since it's already time, or rather almost time, I guess we're going to end here. We will schedule another session soon. Please stand by for our announcements. And okay, other announcements. All scores must have been emailed by now. If you did not receive your score, it's either one, you did not provide your email as of a few days ago. Two, we didn't receive your answer, so that means your time limit ran out. it said there in the testing portal that um that you that please ensure you should click submit before the time limit ends in order not to cause problems. Oh, Joseph, I think we already sent your score. Yeah. Okay. Just put your email in the website for the next contest. And then yeah. So if you did not receive the email, it's either one, you did not provide your email, two, we did not receive your answers because you failed to click submit, and three, what's this? And three, you did not take the test at all. So if you have any issues, please contact us at this email address, so penchickomo@gmail.com. And during the contest period, we also contacted those who ran out of time. Okay. When's the next POMO? For someone who hasn't joined POMO 1, please wait for further announcements also. So does anyone have further questions about the problems discussed so far or about POMO? Okay. When is the POMO finals? We also cannot disclose it. Yeah, just wait for further details on that. But stay tuned for POMO 2 and POMO finals. We'll also release the answer key after the second live solve. So yeah. And in the second live solve, hopefully we have more time. We'll be discussing the rest of the questions. So that's part 2, 9 to 15, and then part 3. Okay. Will a write-up of POMO 1 be posted? We hope to do so. We also have prepared solutions. But we organized this one so that you guys can also ask questions on the spot. Okay. Do we have other questions? We may also send a feedback form after the second live solve, so wait for that as well. And yeah, we hope you enjoyed the first live solve session. Again, please wait for the second one, the announcement on the second one. And you can also discuss all the problems in the POMO server if you want to. So yeah, I guess that's it. If you want to stick around and chat, you could. Otherwise, thank you for attending.